Good morning, everyone. My name is Mandar. I'm the Technical Solutions Professional for HPC, taking care of Australia and New Zealand. Just out of curiosity, a show of hands, how many of you are using Azure HPC capabilities? No? That's good. Because it gives me a chance to tell you what I've got, right? And you have you started a journey on Azure or any cloud yet? Some of you? Yeah? Cool. Okay. So, great. So, over the past 8 months or so, Azure has invested lots into HPC. Lots of new services have come up. And I think this is a great platform for me to introduce you to all those services. In the area of traditional HPC for computational fluid dynamics, reservoir simulations, all those genomics workloads, but also in the area of artificial intelligence where you want to have deep learning using distributed MPI, sending these distributed training using MPI, leveraging the state-of-the-art in NVIDIA GPUs on Azure. So we're going to talk about these two services today. Ready for how to create clusters on Azure within minutes, how to submit jobs to those clusters, and how not to get charged, how not to have a hefty bill. Because typically, people think of cloud and they start off thinking of spinning up these VMs. Oh, my meter starts running, I'm going to get a hefty bill. Not anymore. So we'll see what these services are, and then go on to machine learning. Before that, I just want to share some perspective from Microsoft. How are some of our customers using the big compute platform on Azure? So various industries, we get interest from various industries. We can't tell the names for confidentiality reasons, but there have been a couple of publications on our websites, how Azure has been helping a global drug development company to find a cure for Alzheimer's disease. Similarly, in the area of manufacturing for circuit simulations, how are they bursting their workloads onto Azure? And in the area of automotive, smart cars, how to retrain their deep learning algorithms using GPUs. There are a couple of autonomous driving companies who have been using Azure for their needs. So that's one of the examples of Neuro Initiative. It's a health provider trying to find cure for Alzheimer's disease, Alzheimer's and Parkinson's disease, and they have been leveraging Azure HPC to cut off their drug development times to approximately half. Couple of great comments we've get from our customers. One of that says that we have 15 minutes to spin up new nodes, and they're bursting to thousands of cores onto Azure. So let's see how to spin up these nodes, HPC nodes on Azure in minutes. Okay. And while we are also working with lots of customers, we are also trying to optimize our platform. How can we give you the best? Couple of benchmarks we have done on Azure in relation to Ansys Fluent. What happens to the performance when you scale up the resources, when you scale up the infrastructure? Over here, this is one great slide here, which shows that we get a near linear scale up in the performance as you scale up the resources on Azure. I'll tell you what this Azure HB series is. It's one of the newest additions to the VMs. We've got near linear scale up over here, up to 84% scale up in against to the resources on Ansys Fluent version 19.2 when we were testing these race car models comprising of 140 million cells. When we compare to one of the top supercomputers, which is in the top 100 list, Azure came out to be approximately 12 times faster. There's some other benchmark cases we have done. Star CCM is another one. I'll show you in a minute. But really what we, working together with the Azure engineering team, what we also try to do with our customers is to sit with them, work up with an architecture which could be the optimal compute resources which could be helpful for your workloads, how to have this scalable storage implemented side by side, and how can we embark you, or how can we help you to accelerate your workloads and your productivity. So let's see how can you leverage these HPC infrastructure on Azure. Two things, we'll be seeing how to provision a cluster and how to do deep learning using machine learning. So that's one of the examples which we have built, reference architectures using CF or CFD on Azure, catered for OpenFOAM, ANSYS, and also other software tools, star CCM, and so on. We give you really the, it's up to the user what they want to do. Do they want to, this is us, this is where we are sitting, the engineer's premises over here. What do they want to do? Do they just want to have a simple workstation, or do they want to fire up different clusters on Azure? And associated with those clusters, how is the file system going to be like? So we also have a triage. How many cores do you want to spin up? How intense your application is going to be, whether it's going to be read heavy, write heavy, or read write heavy. So based on that, we have built up a triage of scalable storage to tie that with the performance, and that's how we have been coming up with these benchmarks. So this is one of the, and similarly like for CFD, we have same thing for rendering, oil and gas, and other industries as well. Okay, so with respect to HPC, what infrastructure we've got on Azure is we like to name the VMs by series. So the two HPC related VMs are named after the H series, which are the CPU only VMs, which come up with these InfiniBand capability. The H series, the HC, and the HBs are the new ones. We've got a mix of Intel and AMD processors in them. The recent additions are HB and HC, but we also have, NVIDIA has been a great partner, and we have some NVIDIA or GPU VMs on the data centers as well. They're categorized as NC, ND, and NV, C for compute, D for deep learning, V for visualization. That's how you go, right? So ND series are great for deep learning applications. And again, some of these do have this InfiniBand capabilities in them as well. In addition, so we've got other VMs as well. So literally what I would like to say over here, it's up to you whether you want to rent a Toyota Corolla or go for a high-end Ferrari. It's up to you, whichever. But HPC, Azure HPC can work on any of these VMs. Also, we've got specialized computes as well. In the area of deep learning, once you have finished training the models on the cloud, you want to deploy it to FPGA. Azure has got some FPGAs as well, where you can accelerate your inferencing from the deep learning models. And what you see down there are the three services to spin up the compute. Cyclic Load is something which we are working since the past 1 year or so. Get your own scheduler, file systems, applications, heavily customizable, and start spinning up those clusters of VMs on Azure. Batch comes up with its own cloud scheduler, so we won't talk about batch much. And again, Azure, if you want to do some high-performance data caching, moving the data or caching the data closer to the compute, that's where the Azure solutions can be helpful. But today we'll be talking about more of Azure Cyclic Cloud. So let's see what Azure Cyclic Cloud is going to be like. Anyone tried Azure Cyclic Cloud? Experienced it? Great. Let me show it. Okay. So I am trying to, so this doesn't work. Okay.
I'll be a mic
That's
stand.
all right. I mean, I'll just. Okay, can you hear me? Okay. Okay, so let's see what this Azure Cyclic Cloud is. Cyclic Cloud is a tool to create. Can you still hear me there? Yeah. So it's a tool to create, manage, and operate and optimize compute clusters in the Azure ecosystem. Great thing, it's free. You only get charged for the compute, and then various ways how you can trim your bill as well. So let me quickly show you how the Cyclic Cloud environment looks like. So I'm going to a portal, and this is actually the Cyclic Cloud portal, which you're seeing over here. Now observe, you can, these schedulers come inbuilt in them for now, but you can put your own applications, schedulers, file systems. This is heavily customizable. So you can pick up your own scheduler, the file systems, the application, and and just start spinning up a cluster. Now let's see how easy it is to spin up a cluster. So I'm just going to pick up a LAMPS cluster for molecular dynamic simulations. So once I click on that with a click button environment, I'm just going to give it a name. Where you want to deploy the cluster, different regions. Azure has got different data centers. So I'm going to go for Azure Australia East. Choose the type of your master node. This could be any of these VMs. It comes, a list appears depending on what you want to do. You can pick up any of the master node. You can even go for low priority. Low priority are the ones which are heavily discounted, great for checkpointed workloads. So most of the customers go for these low priority VMs. And then if you want to go for the execute VMs, the worker nodes, you can really mix and match from the list. If you want to go for HPC VMs, you can select from the list H series or H16Rs and so on and so forth. So you can have multiple of them, and once you hit apply, you can also tell how many cores you want to utilize. Subnet is, you can pick up the cycle subnet. Again, there is a quick start guide which I include in the presentation. Follow the quick start guide to get up to this portal. And once that is done, if you want to install any of the softwares on these master nodes and the execute node, we also have provision for that. So just browse, and you can upload your software files. Here for now, I've just loaded OpenFOAM and NWChem. But really, if you want to install the softwares on these master nodes, you can even do that. And that's it. Once you have done, your cluster is ready to start. So you just have to click on the start button. Now I have configured a cluster previously, so I'm just going to show you that. So over here, I've just created a LAMPS cluster, and observe only the master node is active for the moment. So I have the execute nodes or the worker nodes are not active. So you're not getting billed for it, right? So few other things, you can share your cluster with the rest of your departmental members, okay? You can create alerts. Still, if you want to make sure that you are just staying within budget, you can create alerts through this particular portal. And if you want to submit these jobs, you can SSH into the master node and start submitting your jobs. So we give you how to connect to that particular master node. You can use any kind of a PuTTY environment or MobiXterm, or even the Azure Cloud Shell, connect to that particular master node, and the Cyclic Cloud environment will spin up. Once you're into master node, start submitting the job. So I've already preloaded a file just to calculate the value of pi iteratively. So I'm going to check for the status of the node. So nothing is there. Let me submit a job. All right, so job has been submitted. Let's go back to the portal. Now, if I refresh it, earlier only the master node was active. Now the system is acquiring the execute nodes. Now your meter starts spinning, right? So this is the auto-scalable functionality, which is very important when you're doing this high-performance computing workloads. Once the workload is finished, it will have a timeout about 120 seconds or so, and it'll automatically scale down, so your meter is stopped. So this is one such environment, heavily customizable. We provide you with the templates, quick start guides. So there is a quick start guide if you want to follow up this guide to get started with the portal. Everything has been documented. We provide you with a template if you want to deploy a custom application or you want to have a template for a particular kind of setting or a topology of the network. Everything is provided. Spectrum LSF and so on. So everything we have, and we're continuously adding lots and lots of small such templates into this. Okay. So that's what I had to show for the Azure Cyclic Cloud environment. But the great thing about this Cyclic Cloud environment is to empower the users, give them the compute what they desire when they need. Great for IT management because IT can add the users, subtract them, and then provide some cost budget reallocations and keep an eye on the budget. And great for businesses as well because you stay under your limits, costing limits. Okay. A few more benchmarks. We have this HPC repository if you want to go through it. How to spin up these different environments on Azure. This is a screenshot what I did last night. To this morning, I saw Abacus also added onto the list, so we have that particular thing. So we give you the scripts. If you want to spin up this environment, you can use this script readily. Last week, I spun up for an environment for reservoir simulation within 20 minutes using those scripts. It works. Some more benchmarks for Ansys Fluent in comparison to a bare metal environment with identical InfiniBand stack. Azure came out to be about 24 times faster. So these are the results which we have populated. The same thing goes for a star CCM. So expected a kind of a near linear scale up in the performance in comparison to the resources. So that was with the star CCM, Siemens, and again for computational fluid dynamics, as you throw more resources onto Azure, you can simulate more and more cases in the shortest amount of time. So these benchmarks are available. We are working towards publishing some results in the next couple of weeks. So keep an eye on our website. All right, so that was about Cyclic Cloud. You can leverage that environment for various HPC needs, but really going to in the theme of this conference for HPC-AI, let me show you quickly what we have got for machine learning. This is one customer, how they're leveraging HPC and machine learning services on Azure. Let's take a listen what they say.
People tend to think of Jabil as a contract manufacturer. We are more than that. We're a manufacturing solutions provider. It's a very difficult business. We help customers with taking a product and building it at scale.
We went to the production site and found out the test machines suffers very high false call, around 30%.
Operators have approximately 2 seconds to analyze each one of these images. For some of the boards, they can have upwards of several thousand components on it.
Human gets tired constantly staring at the same stuff. We thought that was a very good opportunity for us to use deep learning to classify images. The model is actually
People tend to...
That's a very good opportunity for us to use deep.
So these guys were classifying these PCB board images manually, and of course it was a laborious job. The human got tired. So what they did is switched on to Azure Machine Learning Services, and once the model was trained, they deployed the model on FPGA.
For model training, we're using Azure Linux GPU VM, and we're using Azure Machine Learning Services to deploy the model as Docker container. Our pilot is predicting 75% of the past images and can correctly predict 92% of the defects.
It's one of the most advanced predictive projects that we've had going on so far. We've been talking with Microsoft about Project Brainwave.
The early test result from Microsoft has shown FPGA is capable of predicting 550 images a second, comparing with a CPU cluster with 40 images a second.
The potential for Project Brainwave is substantial in allowing us to move forward at scale for machine learning across Jabil. Very exciting.
So that's using AI, but again, if you want to deploy these models on the edge, so you can squeeze an IoT, AI, and HPC together. So this is how everything comes together for model training, HPC for training, deployment, and again using the libraries or the AI or the machine learning libraries which are available on Azure straight away. So just briefly, machine learning on Azure. we give you the resources, you can do whatever you want. So we give you the pre-trained models which are available on Azure, so you can ready to use it. Or if you're familiar with the data science tools, we have these tools installed. Jupyter notebooks are now integrated into Azure notebooks, where you can just start coding. You can use various frameworks, TensorFlow, PyCharm, Onyx, Cyclic Load, and so on. Great proactive services. Typically, when you go for machine learning, you're interested in the end-to-end approach, right from data ingestion to model training, and model deployment. So the Azure machine learning services do help you with all these aspects. And again, that is backed by the powerful infrastructure, which I've just shown with the CPUs, GPUs, and also on FPGAs. Just a quick demo, how does that machine learning scene works. If you want to try a couple of machine learning notebooks, we have got this repository as well. If you want to train on various frameworks, if you want to do distributed training using Horowod, or if you want to go for hyperparameter tuning and how can you leverage all these HPC capabilities on Azure, those notebooks are readily available for you to use. So the GitHub repository is machine learning notebooks. So let me show you how the thing works. What is the Azure machine learning service? Now, the other thing is, as I said, the Jupyter Notebooks is now integrated onto Azure. If you just go for notebooks.azure.com, that's where you can start leveraging Jupyter inside your browser. So one such example is this. So I've just it's a Jupyter notebook for hyperparameter tuning using the Azure machine learning services. Now, what that Azure machine service is, this is what the Azure machine service looks like. There are various assets inside it where you can track your experiments, what experiments you have, what we have trained historically. I've done some MNIST training, Horowod architecture. You can go into it and you can see how they have performed historically, what was their training times, and so on and so forth. You can also construct pipelines, end-to-end learning. You can spin up different computes. Again, here when spinning different computes, these are auto-scalable. Observe, I've got 2 computes over here. They are consuming 0 nodes, so I'm not getting charged anything. So once the training is complete, it's scaled down. You get, once you've trained your models, you get a historical list of what models have been trained. You can also import models which you have trained elsewhere in other tools. So that is also possible. But once you've finished training these models, you want to go think about deployment. So that's where you want to package that into images. For example, a Docker image. We also give you the constructs for doing that. So Docker image has been created, and then you want to deploy, whether you want to deploy on FPGAs or compute instances or container instances or Kubernetes service. So all these things are integrated over here. So great tool for bringing everything together, IoT, AI, HPC, in this particular environment. So I won't be going through this, but really, if you go to notebooks.azure.com, you can clone the repository which I've just shown, and that repository is appeared over here. You can go into this Jupyter Notebooks, and you can really run that particular machine learning tasks readily onto Azure. So that's about the machine learning, end-to-end, right from data preparation to model training to model deployment. Great orchestration, leverage different kinds of HPC capabilities. Most of our industries in example for mining industries, they are into this continuous integration and continuous development. They want to train the models again and again, repeated training and so on. So again, with the help of MLOps, you can do that continuous integration, continuous deployment of these model CI/CD platforms. And this supports different frameworks, as I mentioned. Great to do this retraining and great end-to-end process. And that was it. So really what I want to I'll be here for the rest of, hopefully the rest of the day. If you have any questions, please come to me. Happy to sit down with you to go through your workload, understand the needs, and hopefully help you somewhere. Got great tools, great infrastructure to provision these clusters on Azure. Great tools, great apps that show you to provision these clusters quickly, start running them into minutes. And also if you're into machine learning or deep learning, if you want to do custom machine learning models,